Hi there. My name is Daniel Unduka, and I am a graduate student in the Department of Earth, Environmental and Geospatial Sciences in North Carolina Central University. And today, I'm going to be taking you through kind of like an intro in data wrangling with R. As I mentioned, I'm a graduate student. I'm also a graduate assistant at NCCU. And today, I'm going to be taking you through um, some data manipulation that I did in ArcGIS Pro. And we're going to be repeating some of that in R using some of the R libraries that are available to us for manipulation purposes and for wrangling purposes. Um, we're also going to be talking about some of the benefits of R. I'm going to take you through the R Studio, and then lastly, we'll talk more about myself in my GIS portfolio. So this is what your R Studio is going to look like after you must have downloaded R Studio and R. And I'm going to share a link to those. I'm going to share a link to those resources in this video. This is for downloading R. As you can see here, this is version 4.5.0. This is the latest release. I think it was dropped in on the 11th of April. And this is R Studio. Usually these installation processes take you through the best version or the latest version for your device, and it's quick and easy to follow. All you need to do is just accept the default for the wizard, for the download wizard, and you should be fine. However, I would like to mention that with R, there are certain bottlenecks that you might run into if you are opening an R file or an R program as a guest on that computer. So you want to make sure that you are running R Studio as an admin. And once you run your R Studio, you should see this screen right here. Now, what you're looking at is a are the three of the panels that are available in R Studio. There's one last more important panel where you're actually going to be writing all your code, but that's not visible right now. And if you open R and this is the view that you get, that's okay, don't fret. This view right here is your console. This is where you can test a few lines of code without directly altering your general code snippets. This is your terminal where you can also do command line scripting in R Studio. And this just holds a queue of different jobs that your R Studio is doing at the moment. This is your environment. In your environment, you're going to have all your variables stored here, as you'll see shortly. History also stores like a backup of all your R processes. You also have connections and tutorials for viewing helper files and videos for R Studio. But one thing I love about R Studio is that it's a largely supported community or code base, and it has a huge community. So there's always help out there, even if you can't get the help from their basic tutorials, which I doubt that you struggle to. There are communities out there. There's Stack Overflow as well, where you can leverage on past discussions that have been had about issues concerning R. But down here in this panel, you have your files view, you have your plots, where any graphs that you plot in R will appear. And here you have your packages. This just it manages the packages that you currently have in your R program. So you see here the packages that are grouped into two. You have your user library. These are the libraries that were self-installed. Whereas underneath you would usually have, yeah, right here, system library. These ones are the ones that come with R Studio. And this is your helper window that shows you a brief description of whatever library you might be looking at. And we'll come back to this in a few minutes. This is your viewer and presentation. Right. So, as I mentioned, we're going to be looking at doing some wrangling with data that I worked with in one of my class projects. And it's death data and zip code data for North Carolina. More specifically, we're going to be taking a large, well, what you call big data, that has death recordings, and we're going to be abstracting or extracting from that big data stroke deaths for male and females in North Carolina zip codes. And we're also going to be taking we're going to be taking advantage of a merge between the deaths and the zip codes data so that we can also have urban rural classifications as one of the fields in our table. I'm going to show you quickly what the data looks like in ArcGIS Pro, how I manipulated it, and what we're going to do differently in R. So I'm just going to extract this here. So we'll give this a second to load, and we should be in. So as I mentioned, this is data from a class assignment or class project, and I thought it might be helpful or useful to just leverage on that for this tutorial. So as you can see here, we have CSV files for that's in 2011, that's in 2015, that's in 2016. And here is the ArcGIS project file, which we're going to open now. It's going to take a while to load, probably 1 to 2 minutes, depending on how quick or how slow your computer is. Okay, so here in ArcGIS Pro, I have my standalone tables here. I have this data from 2021, which we'll be working with. If I just open this up just to show you kind of like a view here on the data. So here we have columns like the death place. Here we have death states, obviously North Carolina for all. We have death year 2021, death dates, month, day, sex, which we'll be working with, age in years, marital status, and all that good stuff. But we also have here the ACME COD, which you could also call ICD codes. So what these ICD codes are alphanumerical codes that represent deaths of different kinds. And the stroke deaths that we'll be looking at today are easily identified or signified by starting with I6. Um, and I think I'll also attach a link to the ICD codes documentation for anyone who's curious about that. But all you need to know for this tutorial is that stroke deaths start with I6. Um, and yeah, these are all the different death types. And the zip codes layer has this attribute table that we'll also be using. And this attribute table, I believe, houses an ID, which is also the zip code, name of the city or county, I believe is city or county, yeah. And has other really useful columns like median, what's that, median income? Yeah, median household income, um, poverty rates, percent minority, I believe it also has food index. It has diabetes deaths. It has a lot of useful columns that we can actually explore. Um, but one of the most important ones that we're going to be looking at and we're going to be using, as I mentioned earlier, is the urban rural RUCA, if I can find it right here. Urban rural RUCA. So this is just a categorization of the different areas in North Carolina based on rural or urban definitions. And that's what the data looks like. And here in ArcGIS Pro, when I was working with this data here in ArcGIS Pro, what I did was I did a summarize. No, I did a merge first using the zip codes, and then I did a summarize to get only the deaths, the female deaths, because what I was looking at for my class project was female stroke deaths specifically. So I did a summarize to get the zip codes that have female deaths. So I summarized the zip codes to get a count, and that count represents the amount of deaths by stroke, female deaths by stroke in that particular zip code. And then I went ahead to map the data. But today we're going to be looking at doing some of those things in R. And let me just put this away. Yes, so we're back to this window here. And as I mentioned, this is not going to be your working pane or working window. So what you want to do is click on this blank page with a plus icon up here in the top left corner, and you want to create an R script. There's also a keyboard shortcut to create one of these R scripts if you like to hasten your workflow and use keyboard shortcuts. This is it for you. Also, if you want to get access to all the keyboard shortcuts, there's also a keyboard shortcut to open up all the keyboard shortcuts, and it is Alt-Shift-K. And here you have your cheat sheet for everything R. You're welcome. But we're going to create a new file, a new R script, and should we go ahead and title this? Sure, let's just save it. So we're going to title and save it. Let's do data science. Let's do final project. And then let's do death data wrangling. Now that we have this, we're going to look through um we're going to look through a few things here. But importantly, it's we need to import some libraries that we're going to be using because there's base R, and then there are libraries that help you um, use some of the basic commands in R, and it's just like um, it provides you with more packages, more libraries that help you with data manipulation. Some of the things you can do with R, but they can be a little code intensive. So there are libraries that um, kind of extract or abstract, I should say, some of all those complexities and gives you more readable, more usable code. So one of those libraries, one of those really great libraries that you're going to need to learn uh, is tidyverse. Code libraries. Um, and then, so when you want to install any library, you use installer packages, and the package we want is tidyverse. And then I'm going to be using command shortcuts as well to run each line of code. And that command is Control Enter. It will be Command Enter, I believe, on Mac, just in case you're following on Mac. And as you see down here in your console, if your package installed correctly, you'd get this success message, and that lets you know that your package has been unpacked and ready to go. One way to confirm if you actually have that package installed is you do a question mark and the name of the package. Oh, Control Enter. What that does is, oh, this is no documentation for tidyverse, and you could try this. Okay, let's try this then. And here we are. So here you see a documentation. As you see, this tab is called help. So anytime we're curious about a particular library and what we can do with that library, this is where that help will appear. So this is for tidyverse. And also, just in case you were wondering what version of R you were using, you can do this, get version. Oh, if I can spell version right. Get version. No, it's get our version. I'm sorry. Can I get our version? It's just a function, I think. Um, methods get our version. Uh, yeah. So I think this yeah, I don't know why that's I don't know why that's not working. But anyways, let's dive into the main reason that we're here, which is the data manipulation for those data sets that I showed you earlier in R, right? Um, so you obviously will have your data in certain formats, right? And for me, what I do is I get, oh, so I have that data from ArcGIS Pro. I just copy them, export them as CSV or Excel, and put them in a folder. And um, my folder, the folder I'm going to be working out of is this folder right here. No, not this one. Oh, yes, that one. Okay. And as you see here, we have our 2021 debts data that we're going to be pulling into this. So what we're going to do is we're just going to copy the path of this data, and we're going to come in here and do loading your data into our. So there are different ways to do this, right? You can take advantage of the GUI, the graphic user interface, which will show you a pop-up. It's kind of like choosing a file. All you need to do is run one line of code, and then it shows you your file explorer, and then you can pick the file that you want, right? And this is how you do that. You just do read.csv, and then you do file.choose. When you run this, it should open up your file explorer and then make you choose a file. For some reason, that's not working. Mm, yeah, sometimes our studio acts funny. But yes, now we get this GUI where you can select the file that you want to assign to that variable debts. And we're going to point to our test 21 data and open it up. And once that's done, you see here we have deaths here, which is this variable. Now, this arrow sign is the syntax for variable definition in R. So like most programming languages, variable definition starts with the name of the variable and assignment symbol, and then the content or the value of that variable. And this is the syntax in R. So this is one way to do it. This is doing it with loading data, if I can type correctly, data with the GUI. You can also, as I mentioned, use the file path. And I think you just paste the path and that should work, right? Well, wrong, because as you see here in this arrow, this console window, R uses that backslash as an escape character. So if you do a lot of programming, that backslash sometimes helps you like um, move to a new line in some cases. Like in Python, you do the backslash n and you can move to a new line. But in R, when you're recording, when you are picking the path, you need to double this backslash so that it recognizes it as a path. Um, and that's the easiest way to make this work. And now that we've corrected that, your death data is, you see there's no error here. So your death data has now been added to this variable. And because it's a variable, every single time you reassign the variable, the values of that variable gets updated. But because it's the same file or the same CSV that we're loading into deaths, we see that the observations and the variables are still the same. Now, the best way, in my opinion, to do this, and I think the safest way to do this, is to create a directory and work out of that directory. This is using a file path, and now we're going to load data using a working directory. So what this does is it sets a path for you as your working directory, and then every single file in that directory is accessible just by name. And I'm going to show you what I mean. So there's a base R function called gets wd. And what this does is it shows you your current working directory. As you see here, I'm working out of this path, but I want to work out of this one here. This is my data science final project under our programming. So what I need to do is I need to copy this as a path and then come here and set my working directory to that path with set wd function. And now I paste this in, and remember you need to add your double backslash so that it can run. And now that that's set, you see this is a variable here as your new working directory. And now if you run this again, you see that it's changed down here to the file or the folder, that we want to be working with. Now that you have a working directory, you can check the list of files in your directory, and it's just going to be a list files, and then pass in your working directory variable. And you see down here, you can see a list of all the files that are available to you in that particular folder. And hold on. We need to set this. Yeah, now we have the right directory. And then when we run this, we see all our death data. Excuse me. And our zip codes CSV file that we're going to be working with. So now we need variables for both data types. We just do a simple CSV, read CSV, and all we need this time is just the name and the extension of that file. So let me show you what happens if we try to do this, right? It says, cannot open DETS 2021, no such file or directory. And that is because you don't have the extension. So you want to add .csv, and that should be fine. Your DETS data should still be here, right there. And then for your zip codes data. I think you want to do zip codes and then do this. And then you read CSV. And then you just pass in the name of your file. And you should read the data. So now you see you have your zip codes here. Now this is your environment. This keeps track of all your variables, as I mentioned earlier. But if you want to actually view a variable, view the table that a variable holds, base R has this view function, and all you need to do is pass the name of the variable into that function, and you get this view of your table. So this is exactly the same table that we saw in ArcGIS Pro. And here we see that we're looking at 17 records out of 122,000. And in total, we have 57 columns. But here we're only looking at columns 1 to 50. And if we click next here, we see the remaining columns. And this is our deaths data. And we can also view our zip codes data. Here we see we have 763 zip codes, well, rows, I should say, which represents each zip code. And then we have 152 columns for the zip codes file, CSV file. Next, we're going to be merging these two data types. So if we merge the deaths and zip code data set, zip codes, it doesn't matter, data sets. Let's make that one. Now we have both data sets, and what we want is a combination of all the information that we have in the deaths CSV file and the zip code CSV file, so that we can further work on that data set and get the desired outcome that we need, which is stroke deaths for male and females in the different zip codes in North Carolina with our urban and rural categorization. So I'm going to show us a few things first. There's ways for you to check through your table, through your data sets, to see if certain columns are available. And the reason why we would want to do this is because for the merge function that we're going to be using, we need to merge by a particular column that is available in both data sets. So, and because we have a number of columns, it might prove to be a Herculean task looking through every single column and then trying to figure out if both tables have zip codes, right? I mean, here we clearly see that there's a zip code column for this one, for the deaths, and we expect that there will be a zip codes column for the zip codes as well. But just imagine if it was a column that was sprung up on you as a task and you've never actually looked through that data set before. So one easy way to check for columns would be you put the name of the column in quotes. So we're looking for zip code. And then you have this in decorator or like in function. And we then pass the data sets that we're looking for. So one of the things that I love about R is that the functions read as sentences. So it can be very easy to understand our code once you've learned the syntax. So what this simply is I'm looking for zip code in all the names of columns in this deaths data set. And I think it returns a truthy or falsy value. And we see here that it says true, meaning that there is in fact a zip code column in deaths. Now we can also check if we have that in zip codes as well. And what I did just now was a keyboard shortcut to copy a line of code downwards, and it is Alt Shift down arrow key. You can also do that in either direction. You can copy code upwards as well. But what we want here is zip codes. So we see false here. And because there is no zip code column in the zip codes data set, that merge that we're attempting to do will not work because we need a common column to perform the merge. It's also important to note at this point that this is a string literal, which means that everything you type in here is sensitive, so case sensitive. So if we do want to check, because I checked manually, and obviously we've seen that there's zip code data in here somewhere, right? So if we do want to confirm that we have anything zip related, because it might not be zip code, it might be zip, or it might be zip ID, or it might be zip number. And I believe in zip codes, there's something, we have a column called zip number. So the way to check if we have anything, the way to check with a string to see if that string is contained in any of the columns might be one way to solve that problem or get around that problem of not being sure of what the actual name of that column that you're looking for is. So there's a starts with function, and what this does is it takes in two arguments, and the first argument is the set of columns to loop through, which, as you remember, is just by calling names, which is all the names of the columns in that data set. And we can say names, zip codes, which is the zip codes data set. And then we want to, the second parameter or variable, or a parameter in this case, since it's a function, the second parameter that it takes in is the actual string that you want to search with. And I believe it returns a truthy and falsy value as well. So we see here, after running this line of code, that there is in fact a column that contains zip, right? And we don't want to go through the data sets to look at every single column and try and figure out where this column that starts with or contains zips is. So one way that we can get every single column that has this zip that we're looking for is to do a select. And to use that select, we need the help of another library, which is called dplyr. So we are going to import dplyr. And all you need to do to import is just the library function, and then the name of the library that you want to import. And I think that's the one. And as you see here, so long as there's no error here, I think it should be fine. And as we mentioned earlier, the best way to confirm that you are actually in declare is to run this helper query. And yes, Control Enter. And you see here in our helper window pane, we see feedback. This is just a nice way to, or a short, brief way to check if your library has actually been installed and is working perfectly, working fine. Um, Now, if you run into any issues with installing this library, all you need to do is just look through the error, and it's probably going to say something like download or couldn't find object with x name or this name. All you need to do is just install the library that it's looking for with this library function, and it eventually it should run. And also remember to start RStudio as an admin. That also helps. So now that we have our dplayer library, we are going to we're going to use the select function. And how this works is, as I mentioned earlier, when you read our code, it's easy to read as a sentence. And I'm going to be doing a lot of that in this tutorial so that it helps us follow through. So we want the zip code columns. Let's name that zip code columns. That's our variable. And what we want to do is inside of zip codes, we want to pipe through all these selected columns that contains zip. Now let's go through this. This is your variable on the left side of this line of code, and on the right side is the values that you're trying to assign to this variable. And the way this pipe operator works in R is that it takes what is on the left, the valuation on the left. The valuation on the left, this is the left, and it does the function or the operation on the right on that value on the left. And then because this is a variable on the left side of the entire line of code, it assigns everything here into our zip codes column. And remember, what we're trying to do here is we're putting a selection of zip columns from zip codes, which is our zip code data, into zip code columns, right? And let's run this. And here we see our zip codes, and we can view the zip code columns, right? So now we see that we have three different columns with zip in them. We have zip underscore num, we have zip underscore text, we have zip, is that a 5? I believe so. But for the sake of the tutorial, we're going to be going with zip num, right? And because, as you remember, when we want to perform a merge, we need both columns to have the same name. So we're going to have to rename that zip num column that we've chosen to use. And let's create a comment for renaming columns. And we're also going to be using this pipe operator, which is only available to you once you've installed this dplayer library. And I forgot to mention, but there's other ways as well to install packages in R. And as I mentioned earlier in the tutorial, this package pane or package window is where you can install things more manually, or like in a click point way. All you need to do is just click on this install button here, and then you type in the name of your package and then install. But with this, you need to remember to check this button to check this box after you must have done the installation. Otherwise, you won't be able to use it in your R program. Um, but back to our task. What we're trying to do is rename the zip num column to zip code so we can do the merge. And as I was saying, the pipe operator is only available in the dplayer library. And that's what we're going to be using to assign a new name to the zip num. So let's say zip codes, new zip codes. And we're going to be taking zip codes. And there's a command, there's a shortcut command for that pipe operator because it's used a lot in our programming. So the shortcut is Ctrl+Shift+M, and it just gives you that operator. Because as you get deeper and deeper into some of these manipulation processes, or you build a workflow for doing some of these processes, it's important to speed can also be important. So it helps to have these keyboard shortcuts ready to use. So, and also this pipe operator helps you it helps you line up different operations. So you could want to merge and then rename your layers or your columns, I should say, and then do something else. So this pipe operator helps you do all those things and then assign everything that you've done on the right-hand side to your left-hand variable. But we are going to rename zip code zip num. So this is kind of like you're reading it from the right to the left. So we're taking zip num and we're renaming it into zip code, and we're taking that zip num column from zip codes, and then we're putting it into this variable new zip codes. And when we run this, if we view our spell review, new zip codes, we should see an updated. Actually, this might be a longer process. Let's just copy this line of code here. But we're gonna just change. We're gonna just change this to new zip codes. If we run this, oh my bad, I picked the wrong line of code. What we need is this one, the one that says that checks if there's any columns that have contained. So remember how we read this is we're taking all the columns that have zip in them from zip codes and putting it into zip columns. And when we run this, but we want to do this from new zip codes, yes. So when we run this and then we run view zip columns, you see that zip num has now been renamed to zip code. And then now we can proceed to do what we want, which is a merge. So merging debts and zip codes data. So for this merge, there are different ways to do the merge. And one way is by using the dplayer's left join. And what that left join does is it takes both data sets and combines them in such a way that um, there is no like it retains the original shapes of both data sets, but because we need an intersection of zip codes that have debts and the original zip codes layer, because that zip codes layer has all the zip codes in NCCU and the debts zip codes have zip codes that have debts. We don't need that left join, which keeps both shapes intact. We want one table as an output that has a combination of both. So every zip code that has debts will be extracted from the general zip codes um, table, but it's easier to just show you. So if we say, what do we name this? Let's call this merged data. Yeah, merged data. So you call your merge function, and this merge function takes the table that you want to merge, the table that you want to be merged to. How do I put this? The table that you want to retain its structure, and then the table that you want to merge, which in this case is new zip codes, and then the parameter that you want to merge by, which is zip code. And when you run this, death, not found. Oh, and this is deaths, not death. Okay. And now, as we see here, we have our merge data. And I think this is a good time to talk about the glimpse function. So the glimpse function shows you, it's like an alternative of viewing. If it doesn't show you the entire data set, it shows you just a snippet of that data set. So if we want to take a glimpse at merge data, we just do this, run the function, and it, excuse me, it shows you like a, um, yeah, like an overview, shows you the first few values of each column, and then shows you every column that is that's available, right? And you see here we have everything combined, even the latitude and longitude, which we don't necessarily need for this tutorial. But yeah, so next up, we're going to be taking out only the columns that we need. For the sake of this tutorial, I think I'm going to, so let's say selecting only required columns. That's not how you spell only. Only required columns. Okay. Now, we're going to name our variable trimmed merge, and then your assignment symbol. And then what you want to do is call the select function again. And then this time you're passing in, for the select function, you're passing in the name of the database you want to select from. And then subsequently, you'll pass the names of the fields that you want in the order that you want them. So I think we can do, it's also case sensitive. So I think we can do zip codes. Oh, my bad. Merged data. I think we can do zip codes. Hold on. Wait, actually, the syntax is to pass your original data through the pipe operator, and then you select um the tables, the columns that you want. Where's my merge data? I think I want to see what this looks like. Yeah. Zip code here. What's going on here? So we want merge data, and then we want zip code. We want, I'm just gonna try this. We want age years. We want sex. We want ACME code. We want name. Actually, I think I want name here first. The um what else? What else? What else do we want? Maybe that's all first. That's all. What else would be useful here? Urban rural workers. Um, Maybe median age. Yeah, median age. And urban rural worker. Okay. Let's do median age. And then finally, urban rural worker. Okay. So if we run this and then we view our trimmed merge. There we go. Now we have zip codes. We have the names of the cities, I believe, and then the age of the person who died, the sex of the person who died, the number of deaths in that city, the total number of deaths in that city, the ACME code, the median age of the population in that city, and then your urban rural worker. Right. So now that we have this trimmed merge, and just to confirm again, the syntax is you pass in the name of the table that you're selecting from first as an argument, and then subsequently you pass in the names of the columns that you want in the order that you want them. Also, you can decide later on to change the order. All you need to do is just repeat the process, but you change this first argument to the name of this new variable because now you have trimmed merge as this, right? So you just need to pass this in. If you do it this way as well, it works, but yeah, just FYI. So next up, we are going to we're going to look for we're going to separate the deaths because now currently we have all death types. And if you remember, I told you that stroke deaths start with capital letter I and E. So we're going to be using that contains with function that we've explored earlier. Okay, so we're going to just filtering all data set, filtering all deaths. Let's call that all deaths. Filtering all deaths for stroke deaths only. So let's call this variable stroke deaths. And then what we want to do is we want to filter. We want to use this filter function. And then we are filtering this data, the trimmed merge, and we're taking any we're taking any AM ACME COD codes that starts with IE. But because these are numbers, because they're actually characters, but you want to make sure. So you just do as character. And then what this also does is that like it gives you the column to search with or to search from. So if you do starts with as character, the name of the column that you want to search, which for us is the ACME COD, and then you pass in the string literal of the name of the string that you want to match. And I just need to close up my brackets here. And then now when we run this, we have our stroke deaths. And just to be sure, let's do view stroke deaths. And there we go. Now we see every single death type here is a stroke death. Every single death type here is a stroke death. And you're kind of seeing how we filtered from over 122,000 rows to only about 5,600 now. And these are some of the interesting and intricate processes that we can run programmatically with R. Now that we have our stroke deaths, we still have repetitions of the zip codes because each of these zip codes represent an instance of stroke deaths. As you can see here with the difference in years, in difference in years for each recorded occurrence. But next up, we want to summarize this and have just one zip code, and then possibly as we do the summarize, we have an average of the years, and then average of the total deaths, and then pick one because all these represent stroke deaths. So just pick the first one, and then pick the first one for this one as well for each zip code or city or county or area. But before that, I think I want to just show us a few I want to show us a few ways that we can start to arrange certain things here. So if we take stroke debts, right? And let's say, for example, I don't know, for some reason we want to we want to see the age years in ascending order. All you need to do is literally an arrange function, and you pass in the name of the column that you want to arrange, which in this case is age years. I believe that age year is not found. Am I spelling this wrong? YRS. Yeah. Pardon me. I believe we need to pass in the name of the variable. Not variable. What am I doing? Excuse me. There we go. Yes. Now if we view stroke debts, we see that the age years has been rearranged in ascending order with 0, which I don't know. I don't know if there's anyone who's 0 years old with that died of a stroke. Maybe this is a specific kind of stroke that is prevalent in infants, perhaps. But yes, the point is we've rearranged this column with age in years in ascending order. Now, if we also can arrange with multiple columns as the column of interest. So, for example, if we wanted to arrange by age and years first, by age years first, and then by sex, all we need to do is just add sex to this, and when we view our stroke debts, you see now that it arranges with age years first, and then it goes to arrange male female, and then returns back to age years, arrange, and then female female, then the last male, and then and so on and so forth, like that. So next up, I think we're going to do next up we're going to do is summarize. So summarize zip codes. Now, this summarize is one of the perfect ways for us to kind of explore the benefits of using this pipe operator that I've been preaching about. So we want to do stroke debt summary. That's our variable. And then what we're doing is we're going to pass stroke debts into our I keep messing this command sheet. We're going to pass stroke debts into into our pipeline, and then we're going to first group by zip code, because this is what we want to this is what we want this summarized to be based off of, right? So now that we've selected zip code as our column of interest, we want to call the summarize function. Not summarize with the Z. Yes, it's a deep layer package. So for the summarize, we want a count for all the zip codes. So there's something in R called the n function, and what this does, it just gives you the total count for each zip code. And then next up, I think we want to have area. Let that be first name, which is the name of this name here. Because you see, in some cases, we have, because of the zip code, we have repetitions. So we want to take the first one, the first unique ID in that column of name. And then want to do the same for sex. We also want we want all debts. We want the average of all debts. That's all. I think that was it. Yes, that's all. And then what else do we want here? Yeah, then urban rural. I think we want the average age as well. And let's do average age. Average age. We'll make it the mean of the age years column. So it's going to give us the average of this for every zip code. And then I think lastly, we want to do our urban rural classification. So we'll do first for this one, urban rural, because for every zip code, it's either going to be an urban zip code, no matter how many times it's repeated, or a rural zip code based on the classifications. Just need to make sure here that we have all our commas in the appropriate places and everything should be fine. When we run this, runs without error. We have our stroke debt summary here, and then we want to do a view stroke debt summary. And voila, now we do not have any repetitions in zip codes. We've shrunk 6,000 rows into 632 with 7 columns that have zip code, count for each zip code, the area for the zip code, the sex of, well, the first sex that was got in there. This doesn't quite help us actually, now that I think about it, because yeah, you have different, this average could be of different sexes, but not to worry. If we wanted to do the summarize in a different way that preserves this, we would need to take some of all these things into account as well. But say for the sake of doing calculations, for example, if I wanted to do the percentage of deaths in that county, well, I said county, in that zip code that are stroke deaths, this would be a summarize would be a nice way to do that. And then also you have your urban rural workers here. But if all we wanted was just to view that categorization and we did not care about the summarize, I think our stroke deaths has that. So say, for example, we wanted to arrange with sex first, and then urban, if I can spell correctly. There we go. Also, this is another reason why I love RStudio, because it has this IntelliSense and autocompleter. So you're less likely to make some of the more common mistakes as you write your code. Um, but if we arrange this way, we see now that we have all the females first, because it's arranging by sex first. All the females in, oh, wrong table. All the females in rural areas first, and then it starts to show you at some point the females in urban areas, and then the males in rural areas, and then the males in urban areas. Um, um, and you see also it's the benefits of creating variables, because now you have an untouched version of that data that you can work with. But um, back to this summarize, say for example, wanted to use the summarize to perform a calculation, which is the last thing that I'll be showing. For the sake of this tutorial, is mutating your table or your data sets, mutating your data sets. And it is, as described, it is a process that helps you change the shape of your database by adding one column. And so say, for example, if I wanted to calculate what did I say I wanted to calculate? Percent stroke deaths, for example, percent stroke deaths table. I will take the stroke deaths summarized, pipe it through the mutate function. And in that mutate function, I want the you know what, let's actually overwrite the stroke deaths, because I want to use that variable name for the name of the column. Let's overwrite this. So the first argument for your mutate function, like most functions in R, is going to be the name of the variable. So this is going to be percent stroke deaths. So it looks right to me, which will be your count. That one. Multiplied by 100 over all deaths. Or you could do counts over all deaths by 100. And what this will do is it's going to create a new column for you with percent stroke deaths. Once we run this and then we view stroke deaths, we see now that we have an extra column here, percent stroke deaths. And yeah, so we see in a place like advanced, we have 50% of the actual deaths in 2021 were stroke deaths. It's funny here because here we have only 2 deaths in this area here, but one of them was a stroke death, so it accounts for 50% as well. But you kind of get the point of some of the things that we can do here with R and some manipulation that we can do with R. And yeah, I think that concludes the tutorial. I'm just going to share briefly about myself. So as I mentioned earlier, my name is Daniel Ndika. I'm a graduate student at North Carolina Central University, NCCU, and my undergrad was in computer science. And I've since then worked with different companies under the capacity of a programmer, and I've worked as a data analyst as well. And I'm using my master's degree to combine or bridge that gap and work that intersection between um, programming and preferring solutions that benefit um, our environment. These are some of my skills. I'm good with Arcade, ArcGIS Pro, ArcGIS Online, which I should mention. I am currently working on a project that is targeted towards metadata um, extraction from our ArcGIS hub, which is called Code, Center of Data Excellence. And I use ArcGIS API for Python for that, and which I've enlisted here. I'm also good with Python, R, PyTorch, JavaScript. I do web development, UX design, um, Power BI. Some of my operational skills include error handling, technical documentation, employee onboarding, and management. Because at some point, when I was working at a tech firm, I was the lead developer of the little department that I was working with. So I was responsible for onboarding new employees under that department when the department began to expand. Um, Here are examples of a few maps that I've created over the course of my program. This one here was when I was observing spatial distribution of traffic volume and um, air quality, specifically looking at PM 2.5. Some of the image processing that I've done, some of the sample code. I believe this one was for route classification using NCDOT big data. And then this is some metadata manipulation that I did, creating a model for the metadata and the shaping, making a shape for the data for the metadata, and assigning values from a data set, and then checking for completeness of each data set. Yeah, that concludes my tutorial. Thank you so much for watching.